Welcome to Agentic AI for Enterprise 2D. In this video course, we will be covering APIs for agentic AI systems. So key components of agentic AI for enterprise, which we have so far covered, they include training of LLMs, the prompt engineering, the retrieval augmented generation, the RAG which we mentioned, it enhances LLM generation capability by providing the accurate, relevant, and up-to-date information. And now in the fourth video, we are covering APIs. So APIs form the key component for agentic AI for enterprise because it's required to manage the interoperability of the agents. It's required to interact with the dynamic tools, the discovery, the plug and play integration of various agents, and orchestration of the workflows. And when we see the enterprise environment, we also need security. So there is a role-based security and then policy governance. So in this section, we will be covering all these aspects, the APIs and how these APIs are used for agent lifecycle management, the security and policy governance. So need for multi-agent system architecture in the enterprise environment is there because in enterprise environment there are multiple agents which need to be deployed to manage multiple applications which will be co-working together like a cross-functional team with a centralized management layer in an organization. So individual specialized agents are there which manage their own specific business domain, like a payment agent or investment advisor agent will be managing their payment domain or investor advisory domain. So modularity and maintainability is possible in the enterprise environment when we have to add a new agent or new application, or we have to modify or debug any agent because these agents are operating autonomously. So multiple autonomous agents are being coordinated by the orchestrator agent or centralized management layer so that these agents can talk to each other, these agents can talk to the tools, databases, and they're able to produce their specific results. And then the centralized management layer is able to orchestrate the intercommunication between different agents. So each specialized agent can be engineered to utilize distinct LLM models and distinct knowledge bases which are specific to that particular agent's requirement. And these computing resources that way can be optimized for cost and performance of specific tasks in an enterprise. So what is the role of orchestrator in the agentic AI enterprise? The complexity of coordinating various specialized agents is managed by the orchestrator. So orchestrator is managing the intent routing, that is the context is being managed. It ensures that context is preserved through the shared memory. It also oversees the execution of delegated tasks. The centralized orchestrator agent can delegate the tasks to specific autonomous agents to execute. So handling necessary fallback logic, such as in case there is a requirement, the human in the loop is required that is also being handled by the orchestrator agent. So for enterprise scale deployment, the LLM architecture needs to be augmented with tools for orchestration. And then we also need governance and agent lifecycle management. Because when agent is speaking to multiple agents, the orchestrator, when speaking to multiple agents, it has to manage the context. So the context is derived from the user prompt. So what a user is requiring, that context is managed and the order is broken up and given to multiple agents to execute. So the role-based security, the governance of the uh, execution, that means it orchestrator, the LLM architecture it has a feature to govern whether what a task it is supposed to do, whether those tasks are being implemented or not. And then there is the agent lifecycle management. So this is a sketch diagram which shows enterprise grade multi-agent system and its orchestration. So at heart of the enterprise grade agentic AI system, we have the orchestrator. Orchestrator is able to communicate to different agents. It also is able to communicate with the enterprise database as well as short-term memory where it manages the context. It also has capability to speak to different external tools and APIs so that overall goal of enterprise can be managed. So critical API features which can enable agent autonomy are function and tool calling. So API should have the feature to have a function calling so that a specific function which is required by the agent, like to fetch real-time data or trigger some external operations. So those calling facilities should be available in the API. So thereby it can extend the LLM model's capability for beyond its pre-trained knowledge. So this capability of calling various functions and tools is very crucial for task automation. So seamless integration is possible. The customer relation management platforms and database in other core applications, they have to interact with each other so as to provide the CRM function for an enterprise. API design and definition for LLM to use a tool, developer has to describe the available tools functions to the model. So model is trained to follow the API capability. So every LLM model has its own APIs and they have their own capabilities where they can call various functions and tools. Typically, these are done through a system prompt, which details the name of the tool to be called, its purpose, and required input parameters. So these input parameters are as per the API design of a particular LLM model. So in case of enterprise, there is need for advanced execution where a parallel function calling feature is available, where one agent can call maybe more than one agent. So multiple agents should be possible to be called in the production environment altogether. So that can give the efficiency of the overall application. So context management and state persistence. This is another important feature for the agent's memory. Agent's ability to recall past interactions and maintain state over long sessions is mandatory. for continuity and coherence, because robust in-session context improve the personalization and continuity of any application. So there is a context window where models like Google's Gemini 2.5 Pro, it offers more than 1000K tokens context window. That means it has the ability to process more than 1 million concurrent sessions. So this kind of capability of any model and environment makes its utility for the enterprise. So there is a long-term memory and grounding RAG. There is a vector database. So every enterprise will have RAG storage. There will be a long-term memory where all the models training data is there. It ensures access to real-time proprietary and domain-specific data. So why we are using domain-specific data? Because this data is verifiable and traceable with its capability. It's essential for enterprise regulatory compliance. Because any output produced by the enterprise needs to be auditable. So context engineering for persistence, it is required to manage the state effectively over long-running processes. So LLMs decide and summarize only required context to persist, because based upon the prompt, LLM decides which context needs to persist. So that optimizes the cost and capability. So these are some of the features which LLM architecture requires for the enterprise grade agentic AI. So in this slide, we are comparing different vendors like OpenAI, Google, Anthropic, NVIDIA. So each one of them have their specific focus and specific capabilities and specific APIs. So in the first column, we are seeing the strategy focus area, like NVIDIA focuses on infrastructure and its performance, whereas Google focuses on governed enterprise deployment. Anthropic focuses more on compliance and safety features. So second column names some of the popular APIs of each one of these vendors, and target enterprise profile, it's listed on the next column, and key differentiator of each vendor is given in the last column. So what we see, Google, it's a leader in multimodal agentic AI, which because it has the capability to manage very large number of contexts. So it's able to integrate multiple agents. Anthropic focus more on compliance, so it also ensures output consistency. NVIDIA focus is on performance optimized inference layer. So in this slide, we are listing various vendor strategy in greater detail. Agent kit for agent lifecycle management and developer integration is done by Response API in case of OpenAI strategy. Whereas Google leverages massive cloud infrastructure, which it has a Vertex AI agent builder, which provides multi-agent orchestration, and it has governance hooks through its cloud infrastructure. Anthropic strategy is Command R plus model, which is optimized for RAG and conversational AI. So architecture has focused on data privacy, safety, human in the loop creation. It excels in rapid prototyping. So whenever we need a rapid prototyping where we also need user-validated workflows. We can use Anthropic, but if we are building an enterprise-grade application, then Google Gemini is better. NVIDIA strategy is more on managing the performance of the infrastructure for the AI environment. So regulatory compliance and data sovereignty. So we are giving a special focus on regulatory compliance in case of an enterprise. And there are specific regulations for different sectors like finance, SOC 2, and healthcare. HIPAA is the regulatory compliance framework. And similarly, government have the SOC 2, and there are government also have certain data retention and other controls required for like data residency controls. So for these, we also need um, facilities to be provided by the platforms. So need protocols, interoperability, securely, efficiently across frameworks and vendors. So I am listing down various popular frameworks because as new and new requirements are being forced in by the industry, gradually there is a standardization also emerging where organization can interoperate across multiple LLMs and multiple agents which can talk to each other and may use a specific LLM for a specific capability as per the requirement. So Model Context Protocol, which is from Anthropic, enables secure two-way communication between LLMs and external tools. Agent-to-agent protocol, which is promoted by Google, it's built for agent-to-agent communication, which is regardless of vendor or framework being used. It enables agents to discover, collaborate, and execute multi-step tasks, whereas IBM has ACP protocol, Agent Communication Protocol, which is a RESTful protocol enabling persistent and secure agent conversation. So focus of ACP is more on asynchronous, scalable, and observable execution. Then similarly, SLIM protocol by Cisco, ANP protocol by ID, which is ideal for agent discovery and negotiation across the domains. And then there's a Agora protocol by University of Oxford. So these are the protocols which help to interface specific tasks between the agents, between the models, agent to agent, asynchronously, or support streaming, pubs of real-time routing for high speed in case of Cisco. So now, which protocols to be used by the enterprise will depend upon the specific application requirements of the enterprise. So there are other important protocols which are evolving quickly. They are agent gateway protocol, which is a message routing between agents and the external systems. So AI, as we know, the agentic AI is one of the area which is growing very, very rapidly, and new tools and protocols are coming every day. And then there is a standardization which will be happening over the long period, but there will be a de facto industry standards which will emerge based upon each tool's specific utility. So the some of the de facto standards which are emerging is LangChain. LangChain standard JSON for the tool metadata. There is a function call protocol by OpenAI, which is schema enforced function execution. There is a task definition frame format by Stanford, so which declares task graphs and coordination. Agent operating system runtime, which is managing stateful long-lived agents in an enterprise setting. Then there is a RDF by Semantic Web. So it's a linked data agent reasoning using a protocol which is Spark query language. Open Agent Protocol, which is community push forward, which is for cross framework interoperability. So as the AI is maturing, one of the important thing which will happen will be maturing of the protocols like Open Agent Protocol, which community would be using cross-frame. So also there are implementation frameworks and design patterns which are emerging, which will ensure the reliability and audit of the enterprise AI applications. LangChain is one of the de facto standard emerging, which is more for single agent pipelines. So single agent pipeline means there is a centralized agent which can interact with different LLM providers and data sources and tools and vector databases like RAG. So LangChain focuses primarily on flexibility and enabling a single controller agent to orchestrate calls to different models and tools. So if there is a single agent architecture for any enterprise application, LangChain is emerging as a standard. Autogen is explicitly engineered for multi-agent conversation. So it has an orchestration centralized agent which can orchestrate between multiple autonomous agents and help them solve a cooperative problem. So Autogen is therefore a preferred choice for implementing high-level orchestrator specialist pattern required for MAS architecture. So Autogen MCP, which is a server, and then there is a MAS architecture which they have promoted. That's we'll be discussing in later on sessions. Is becoming one of the another de facto standard. So as we see, AI platforms are managing lot of other agent lifecycle management, governance, human in loop, audit, and continuous improvement kind of features. Continuous, basically, there are mission critical systems which are integrated with various distributed systems, storages, tools in an enterprise. And when a centralized agent is orchestrating its state management and state recovery, timeouts, auditability, logging, so all these, there are lots of compliance requirements and operational requirements. So these functions are normally handled by the AI platforms like Google Cloud and Amazon Web Services platform. So in this slide, we are showing a real world case study of enterprise agentic system for appointment booking. So in the appointment booking system, there is a planner layer where the user interacts with a supervisory agent and requests for appointment with a doctor. So there is a agent which is autonomous agent which is checking the availability. So it would check the availability of a doctor check the availability with the specialization. Then there is a booking agent which will set the appointment. It also has features like rescheduling, cancellation, and sending confirmations. And then there's a FAQ agent which can answer various frequently asked questions. And it can also fetch doctors' database for any specific queries. Now, if we see the implementation of this agentic AI architecture, it's done on a platform. So in a agentic AI platform, we have got aggregator agent, which is again speaking to long-term and short-term memory, which is also doing the planning, which is doing the uh, speaking with a generative AI model. Then there are autonomous agents, which are again speaking using various MCP servers and speaking to different local data sources. There could be need to go to a search server, or another agent might be speaking to the cloud engine. So this is how on-ground implementation is done using agentic AI platform, which also do the agent lifecycle management and governance and security and compliance, including role-based access control, etc. So conclusion, agentic AI intelligence isn't confined to a single model answering a prompt, but instead it's emerging from collaboration between different agents, and each having its own memory, its own tools, goals, and ability to act autonomously. So agentic AI, we can call it a team of specialists. Some agents do the planning, some are doing retrieving of data, some are doing reason and debate, and others are doing the execution of tasks. And just like any high performance enterprise or any high performance team in an enterprise, it it's just not about the individual skill, but it's about coordination, communication, and orchestration. So what we see in case of enterprise scenario, APIs play the most important role here. Thank you.